the recording. So it's now recording. And so like I was saying, we have here the topic for today. So you can click on this link. There's some slides there that you can take a look at. So let me open them. All right, and you can download those slides if you'd like. Okay, so let me do. All right, so let's actually start there. Let me share, I need to share this document. Okay. All right, so we are going to talk about, today is, and just disregard this is last year's slides, but basically the file system. And you should know what the file system is. You know, you've been using it all semester. So today we're just going to provide a little bit more detail about it. So the Unix file system, so the concept of file system, what it is, obviously there's some commands associated with it. And then this idea of, I have a handout that I'm going to go through, but it's not going to be a homework assignment, okay? So this won't be a homework assignment, although there's a document, I'll show you where it is, because it's very nice to understand the concept of, you know, mounting, so mounting things into the file system. So to the file system, okay? So it'll become very useful for our understanding, basically. So as you know, we've talked about Dennis Ritchie, who came up with this, this core idea of how to organize things in an operating system, right? With Unix in the 70s, 1974. So on Windows, we know that we have these things called the drives, right? So we have the C drive, the D, E drives. We're familiar with those. On the Linux side, the file system is a type of an abstraction, right? Instead, we just have this file system, and we can attach, let's say, disks, etc., to single points in the file system. So ultimately, the file system is a single tree structure. Okay, that's what the file system is. It starts at whenever we get into the computer and the prompt, we get into the root directory or the root folder, and then from there we navigate into other directories and folders. Okay, but it basically follows this tree type of data structure, and think of it as an abstraction. Right? Instead of looking into the C drive, you can just go into that part of the file system where something is mounted. So the Unix file organization, basically, so all Unix file systems are organized within a single tree structure. And that it's all going to be underneath. So it's all going to be underneath one root directory, which is usually the /. Okay, so it's going to be the /. So let's say that you want to get from wherever you are, you want to get into the root directory. So you would do something like cd, right? And then you navigate into the root directory there. So basically the leaves or nodes in the tree are separated by slashes. So whenever you navigate into a folder, and then from that folder you navigate into another folder and so on, you're going to have, all these folders within folders or files within folders are going to be separated by slashes, okay? So here we have an example of what the file system looks like. So you can see, it starts at the /, and then you'll have another directory, home, and then, your user account, so maybe user, right, seed, etc., depending on the machine you're using, and then within that you have mail, etc. So this tree structure translates into something like this, right? So separated, these nodes separated by /. Okay. Right. So in Unix, there is no, let's say, forest of directory trees, right? So, you know, like in C, you'd have all these directory, you could think of a forest of drives, basically, right? So instead, the idea is that you just have one thing called a file system, and then maybe you can attach something to it, whatever, and that's called mounting. So for instance, you have a drive, and then drive 2, and you just mount it there to the point where you want to mount it, right? And this is where, you know, there's an example in a lab type of thing that you don't have to do, but it's very clear how that works, so we'll take a look at it after the lecture. So, you know, let's say that you have some files. Let's say that in order to make files on a disk partition accessible, right? So you have some files in a disk partition. The disk partition has to be mounted at a specific point. So you can think of it, for instance, as this is the file system itself, this here, right? And then you have a mounting point, which is just, you know, navigating to some folder, some place, node in your directory tree. And then this is your drive, right? So your drive is like home, food, bar, mail, etc. For it to become accessible, this drive into your machine, you'll have to basically connect it. And that is called mounting, okay? And then once that happens, you can kind of see the files in there. Also keep in mind that if there's a file in here, right? Let's say you have a file in there. When you mount the drive, the file becomes hidden, basically. So it's kind of interesting how that happens, where you can hide files. They're still there, but because you have something mounted on there, you can't see it. When you unmount the drive, the file should still be there. So basically, the disk partition has to be mounted at some directory in the file system tree. All right, and that's honestly one of the most important concepts in this. Everything else is just, the file system is pretty simple, is this organization of files and folders, and you know, you have designated locations, okay, for different things. So here we have, for instance, the root folder, right? And you can see here, let's say you had, you know, a couple of computers, you know, a Windows computer. Let's say this is like a forensics machine, right? So you want to do forensics, and you have all your forensics software and so on there. Then you could basically image individual drives from, let's say, a compromised Windows computer, a compromised Mac computer, these drives, and then just mount them at specific points with various conditions, etc. And then they just become part of your file system so that you can take a look at them. Right? So that's the main idea there. Now so that's one of the main concepts, how to add things to the file system. The other concept is, what folders do we have available in a Unix directory tree? You've probably noticed whenever you go into the computer prompt, right, you do ls, you start navigating through the folders, especially when you go to the root folder, right? So you go to the root, let's say you do cd root, and then in here, then you do something like ls, right? And then when you do the ls, you're going to now see all these different folders. So basically, you know, we'll talk a little bit about what they are. So we got the bin, dev, etc, home, library, a mounting point, optional, proc, var, user, and temp, right? So all these different folders actually exist in most Unix systems, and they have specific tasks, etc. right? So let's start with bin. So bin is going to usually be in Unix systems where you have all the existing functions, all the existing processes that you're going to run, all the executables, if you will. So whenever you type something like ls, for instance, right? ls, you know, what happens is there is a path, right? So there's going to be a path variable, right? So let's say path variable in Unix, and that path variable actually has among its members, right? It's got the bin folder. It might, sometimes there's an S bin, and so on, right? And these are just places where you can store individual processes, okay? So in the case of bin, as I said, you know, whenever you type ls, you look up in the path directory, that has bin, and so then you go in here and you find basically that the executable for ls, which remember it's nothing more than an executable little script. So you're going to find that script and then you're able to execute your task. So usually that's what that is for. Whenever you want to do, let's say, we're not going to cover all of these, but let's say like etc, the etc folder has what? Configuration files, right? So config files. You've already done this in your DNS lab, for instance, where you had to configure the DNS server, right? So that in that one, you had a, you know, that's where you update your files, you go to configuration. Home is usually where the users have their desktop, right? So you have your My Documents and all of that. So home, so whenever you create a user, let's say, you know, user 1, right? And then user 1 underneath is going to have its desktop, you know, My Documents, etc. So this is really the organization of it. The lib folder is going to be whenever you have libraries that are shared or used by other processes, right? So you have many executables, of course, here, and they might need something like the libpcat library for networking, network processing, okay? So then you're going to find those files in there, okay? The mount point might be a place where you, like we were talking before, where you might want to mount some folders, some drives from, you know, let's say that you're bringing in from some other source. Okay, optional, so things that are optional in systems you can have in there. Proc is an interesting one that has to do with the Linux kernel. It has to do with the Linux kernel. And it basically is whenever you want to control the kernel, let's say that you're going to run a program. You're going to link a program, what is called an LKM, a Linux kernel module. And you want the Linux kernel module runs not in the application space, but in the kernel space. And so you want to communicate with the module, then the proc is a way for you to do that. So that's a topic that we're not gonna do in this class, but that's what that folder is for, right? So whenever you wanna, so an example of this is when, let's say that you were writing your own firewall. So you write your own firewall, right? And that firewall then obviously needs to be running really fast, right? Because it's gonna be looking at all the packets in real time. And so you don't wanna slow down your computer. So in that case, you would create the firewall as an LKM so that it can access the most raw information of the operating system. And then let's say the rules of the firewall that you get updated could be stored in the proc folder, which is designated for that type of function so that it can efficiently retrieve that data. Okay. The temp folder, I think you guys know what this is. Every time you turn on your computer, the temp folder, you might need some files that are only temporary. And so all temporary files are stored in the temp folder. When you turn off the computer, the temp files are going to get deleted. Right? User might be a place where you store information about users and their applications as well. So that's another folder that you have available there. And then finally, var is, I think we've talked about this, is where you have data that has a tendency to change in size, okay? So for instance, log files is a good example of this. You know, if you have a log file, well, it's constantly increasing, right? And we actually saw this at some point in the semester in one of the labs where we were logging information and it was being stored in the var folder. Additionally, here you could have things like email, right? Another thing that's here is website data. So your websites usually go in var. All right, so this is just, you know, an idea, a brief overview of some of the different folders that we have available in our Unix operating systems and the reasons why we have them. It's basically a type of organization, as you can see. Okay. Are there any questions so far about any of this, guys?
No questions.
Questions, right? Yeah. So you know, this topic is important. Certainly, you know, I don't want to not say that it's important, but you know, it's pretty straightforward, right? So it's basically the navigation. You've already been using the file system, and it's really all about organization of files, so you know where to find things. So you know if you want to configure something, you probably want to go in there, right? If you want to look at programs, you go in there. This is all your data. This is more like variable data over here. This, you know, like I said, is dealing with the kernel. I believe this is actually a virtual only. So I believe that's the case. And then libraries, obviously, you know, programs use libraries that they share and so on. Okay, so this is the file system structure. You can see here bin, you know, it's written out. So basically what I just said, executable files. So all your programs, your commands, your utilities. Remember that whenever you type ls, right, ls in the terminal, that's really literally a program. It's almost like you're saying, you know, ls, kind of like that, but it's in your path directory, okay? The dev, that's for device directory, so devices like disks, terminals, etc., that you can store there. That you can access through there, I should say. The etc, which is system configuration files and executables. You can find something like the initd folder. The initd, traditionally in Unix operating systems, was a place where you stored boot scripts. So boot scripts are usually .sh or shell scripts that initialize the system. Right, so, you know, when you had like in the old days, you had like routers, etc., that ran on Linux. You know, all the configuration was on those. If you did something like a Raspberry Pi, right, which uses some kind of Linux, mini Linux operating system, and then you wanted to configure that as a router, which you can. So it, you know, basically what you have to do is you have to write some scripts, put the scripts in initd so that they're boot scripts, and then immediately as the system starts up, you know, it becomes a router. Or let's say that you're using a Raspberry to create, to control like a little robot car, same thing. You want it to become a robot car, you would write some little shell scripts in there, you know, that might be called C++, C++ files, Python files, etc. But ultimately, they convert, you know, by running these scripts, you're going to convert that either Raspberry or whatever it is into a router, robot, car, whatever, right? And that's the, usually then, that's the point of something like initd. The home folder, as I said, you know, is the user's home directory. So you'll get to play with this a little bit more with the home folder when you do your homework assignment next week. So next week's assignment is pretty easy. It's just user account management. So, you know, I think a lot of the labs that we have left, certainly, are very easy now. Shouldn't be any problem. And so in that one, it's basically you just follow the instruction, or not the instructions, but the kind of the logic, the suggestions on how you create user accounts. And then you'll see that when you create a user account, you know, for that user in the home directory, you'll have a folder, right? Like seed for that account, and then it's going to be associated with its own desktop and so on. Right, and that's all in the home of the root, you know, and root and then home folder. Lib, as I said, it's a location for shared files. Usually, like you know, like lib suggests like library files. So the libpcat file for networking, you know, and various other files that might be needed by programs. Opt, as I said, is you know optional software, you know, that you might want to organize there. You can do that. The proc, I kind of went over this already. You can see here, it's called a process directory. It has to do with the kernel system. You will not in this course do anything with Linux kernel modules, but actually, if you take 454, there is a firewalls related lab there where you get to see how that works. Basically, the proc holds files that can help to configure processes running in the kernel. So as I said, you know, if you think of a computer, right, you can think of this as the application space of the computer, and this is the kernel itself. What the kernel is the code running the Linux operating system itself. That is at a very low level, right? Instead of having a program kind of outside the kernel that the kernel manages, this is actually within that kernel. And so obviously this is going to be much more efficient, fast, but you know, it's more problematic also. So, you know, let's think of networking, right? So the kernel obviously handles dealing with packets. So then if you want, you know, if you want to build your own firewall with your own C code, you have to create it through a Linux kernel module that would then hook into these packets. But then, as you know, as you might imagine, you don't want to have to remove the kernel and then, or sorry, remove the Linux kernel module and then add it back and then remove it every time you want to make a change. In particular with firewalls, you just want to have the access control list, you know, kind of updated outside. And so you want them to interact and send the data back into the kernel. So the proc is usually a good way to store that info, okay? Temp folder, you know, as the name implies, pretty straightforward. Temporary directory, delete it. This should say on system restart. So if you turn off, you're going to lose those files. Sometimes if you delete a file in temp, you're going to corrupt something in your operating system as well, or at least something will stop working. The user, it's a user and, you know, and admin commands. It's also for programs and executables, but more specific to the user versus the general operating system, for instance, okay? So just keep that in mind. We have the var folder, and the var folder is actually, as I said, data that varies, basically. This is a var, you know, variable, okay? So when you have this data that varies, you know, like I gave the example, a good example of this is log. So we did a script in Perl, I believe, where we were logging in some things into some files. And so that can vary quite a bit. And so that folder is for that. Also emails come and go, right? So you're updating your email probably every day. If you have email services enabled in your Unix operating system, printing, web is another one, you know, and so on, right? So that's what those folders are for. So you can see here is the basic sophisticated architecture. Everything starts at the root. You have underneath it like bin, home, etc, user var. And then under home, you'll have like user one, This is user one, seed, and then within seed, documents, desktop. And you might have something like a mount point. And then this just implies if I had another disk, and literally, like if I had another computer and I just create an image of that disk, right, of that second computer, that whole, and maybe it's a Linux computer, and I grab the whole thing as an image, then I can take it to this computer and just mount it. Take the whole thing at the root, obviously the root of that disk, and mount it to a mounting point, and it just becomes part of the file system seamlessly, okay? And that's what the handout that I'll describe today, which again is not a lab. You know, I'm not going to create a link for it, so therefore you should not. You know, sometimes I say things in videos, but students still do it. So there won't be a link for this, but I still want to go over the discussion because I think it's a very nice demo or you know, document, let's say. So files, now as far as file system concepts or commands, well, you know, you've been using these already, right? So you've used these, let me just scratch this. I can't erase, unfortunately. But what this says is, you know, CD, and then you can do like dot, right? So that you can see that those are being described here. Other commands are like ls. I like to use ls-l quite a bit. This allows me to, you know, view the contents of a folder. It's a listing in a nice readable way. Now, whenever you do like dot or dot, right? So you guys do this. The dot actually in Linux implies the current directory. So whenever you want to specifically refer to something as use the current directory, by default, it usually refers to the current directory, but it's actually referred to by a dot. Now, if you have two dots, that means the directory one level up, all right, one level up. So for instance, if I do the pwd command, remember that gives me the full path of wherever I am. So let's say that I'm in the user folder. Then if I do pwd, it's going to give me home user. Then now, if I cd dot, and then I do pwd again, I'm going to end up in home, right? Because that just means that I've gone up one level. And so the dot, as I said, just means directory one level up, okay? So, you know, pretty simple, you know, pretty straightforward. Symbolic links, basically, this is something else that you might see in a folder. They're basically a pointer or alias to another file, okay? So whenever, let's say that I want to create a symbolic link, right? I want to create a symbolic link. And instead, you know, I have some script, and that script, you know, might change or whatever, you know. The script is called check server 1, and it's going to change to check server 2 or check server 3. But I don't want to remember that name for whatever reason. Instead, I just want to type Python Purdue, right? So what I can do is I can create a symbolic link, right? And the symbolic link basically then is like this. So I'm going to say ln-s symbolic, and I'm going to link check server 1 py to the word Purdue. So basically, now that I've done this, whenever I type ls-l, it's going to show me, you know, the permissions here and then the word Purdue. And then there's usually like an arrow type of a thing that shows you, okay, Purdue is actually, although you might think of Purdue as the file, it's actually a symbolic link to the real file, which is check server 1. This is an issue that will come up in your Hadoop configuration, for instance. So that's why I really like that Hadoop project A, because, you know, really when you configure everything, you configure it as Java. But then the symbolic link of Java is going to be for, I don't know, JRF, you know, .21.2021, you know, something. So it's usually something that varies, and you have to be kind of careful there And so whenever you're hard coding this in the configuration files, it's better just to hard code the Java, and that way you don't have to go into the files and change whenever this file changes. Okay, so you just do the symbolic link. And then we've talked about ownership, so I won't repeat this. This is something we've talked about already, set UID and ownership. But those are commands that are could be related to the file system, obviously, when you're dealing with access control. Set UID we've already described, so I'm not going to describe that again. Okay. All right, and that's basically, so this is just a short set of notes that I had. So that talk about the file system. All right, and you know, it's pretty simple and straightforward. All right, so let me close this. Now let's go to Brightspace. Let's go ahead and go to Brightspace. All right, and you can see here in Brightspace, again, this is where we are in the semester. So we will do this on Thursday. So today, where are we? We did, I think we've done, we did this, right? We went over this, yeah. So we went over this before spring break. Okay, and then today we're covering file system analysis. Plus we're gonna do some scripts on Thursday just to cover a few miscellaneous topics. Then you can see we have Snmp. Okay. Yeah, so we're almost at the end of the semester. If you look, you know, we have basically this lab, the Snmp lab, which is just really one lab, and then the account management, which is next week, and then some scripting topics. So we're getting close to the end of the semester. So keep that in mind, right? So if you have all these projects, project A, project B, you know, make sure you're working on them as we wrap up the semester. Snmp is a topic I really like. You know, it's very easy, I think, but also it's very, very interesting. We'll see that. And that we'll cover this next week. We'll start the lecture for that. All right, so also I should say, before I forget, we have an exam coming up, right? So we are on March 22nd, so you guys should be seeing the calendar now. So before I forget, March 22nd is today. Notice that March 29, we're covering namespaces and Snmp or Snmp type approaches. And then April 5th, we have exam 2, okay? So remember, exam 2 will be just like exam 1, exactly like exam 1, probably a little bit shorter. It'll be comprehensive, which basically means it could cover anything that we've covered so far in the semester from the beginning until, you know, basically the 31st. So it'll cover some Snmp, file systems, namespaces, you know, user accounts, etc. Usually, though, it's mostly about the topics that weren't covered in exam 1, but again, there could be anywhere from a couple of questions from before exam 1 to, you know, a lot, half of them. So make sure you study a little bit for these. Okay, any questions about the exam, guys? Exam 2?
I don't think so.
All right. Excellent. All right, so anyway, I just remembered, you know, I wanted to mention that we have an exam basically in 2 weeks. All right, so now let's go back to Brightspace. We're there. So I'm going to click on Brightspace, and you can see here, so this week, we're exactly here. On Wednesday, we will do some scripts that relate to this. I'm going to update this a little bit, this description. And then today we are in file system and file system analysis. So you can see I have, of course, I have this file. So this is, I believe, the file I just went over. If I do download, I just put it in both places, the calendar in here. Yeah, you can see this is the exact same file that we just discussed a second ago. And then in here, making sure, there's a script here. Right, so these are the scripts that we're going to do in class on Wednesday. So don't worry about this yet. I will update this, but we're going to do some scripts, and basically you just have to finish them. So I'll provide some basics of them, a little demo here and there, and then I'll set a few problems on this document. So I'll change this. Okay, but it should be pretty easy at this point. To kind of just practice. They're going to be Python, and then there's some slides here as well. Oh, I need to download that. And it's the same thing. So sometimes I just duplicate. So let's go to open. Right. And now I need to share this document. There it is, I believe. And as you can see, it's just the same thing. As I usually do. I have a more digital version of file system analysis. I really like this cartoon. It's a tree, right? So it captures the idea. You can see there, it's got all the folders, home, bar, etc., and then the things in a D, right? Like we discussed a second ago, the user can have an SBIN, a local file. We have the var, which has mail, right? Logs, the home, which has, Vanguard, all the different users. And then this is the root, of course, which, like the root of the tree. And of course, there's the system administrator working diligently. All right, so anyway, that's, the topic. You can also read through this. Remember, always read through these files. It's pretty much everything I just said, kind of just laid out in a little bit more detail. There's the file system hierarchy. As we know, files are central to Linux. We've talked about this. We've talked about ownership. We've talked about all these topics again. So access control, just, this we've talked about. And so this, because it's the file system, and then it gets into these ideas of, dealing with folders, right? So in this case, maybe creating a compressed version of a folder into another folder, for instance. Okay, so it talks about all the different devices that you can have in the device folder. Okay. And then here's just a description, pretty much what I've discussed already, so you can just read through this as well. Now, mounting and unmounting is really one of the commands that I'll talk about. I've already addressed it basically. The idea is to mount the file system to the point of a tree. You decide where, right? You wanna do it and what. So, for instance, you might have a device. Okay. You might have a device, and then you're gonna mount it into a point in the file system. So the document that we're going to look at in a second, you could follow that and do it you can do it on your own. All right. If you do it on your own and want to submit it, I can give you bonus points if you want, but it's not required. Okay. But the exercise, I'll talk about it in a second, is kind of interesting. It assumes like you're a forensics person, and then how would you mount information into the file system? And then there's mount and unmount, right, to add and remove, you know, a file system to a point in your own in another file system. So you can see this here. It's kind of exemplified. You know, you have root, you have home and user, right? And then you can mount, you know, let's say this entire structure from another location. And then as far as forensic tools, there's a lot of forensics tools out there. I guess whenever you talk about the file system, everybody talks about the artifacts that are stored in the file system, right? They want to, you know, they're doing some kind of an investigation of your computer or a computer that they've confiscated. So they want to take an image of it. They kind of want to make it only read only, so nobody can modify it. And then they want to, you know, navigate the file system, look for files, look for deleted files, you know, etc. Right? So that sort of falls under this idea of forensics. So there's a lot of tools out there, FTK, the sleuth kit, autopsy, etc. Again, I'm just mentioning these things. We're not going to be doing anything with them, but just for your own information, they're available. So what we're going to do is a case, basically, after this, just to kind of take a look at some of the logic behind this. I should stress, you know, one thing that, you know, it's important, I guess, in a, you know, as part of the syllabus in your system administration, right? In system administration, you guys. So I have to throw in this topic. So as I said, this week is very miscellaneous topics. Oops, why is this not writing? Okay, so it doesn't want to write. Anyway, so ethics as a system administrator, what does that mean? Well, it means that if you, let's say you work as a system administrator, right? So what's going to happen there is that you have all the passwords, right? You have all the administrator rights to a lot of computers. You can SSH, you can do things like that. You can get, you know, the root. And if you know the root, then you can probably access the, let's say there's a Linux server and there's a var, and then there's an email, you know, functionality or something like that. You might have access to look, you know, maybe not at encrypted data, but at metadata, or you can actually modify things related to users, you know, all kinds of things. Okay, so just keep in mind that, you know, even though you're a system administrator, it doesn't necessarily mean that you're all powerful, right? So there is, in fact, a type of a code of conduct of system administrators. This is in your book, but I've thrown in these slides here. I'm not really going to talk about these things. I mean, I'm sure you guys have taken a lot of ethics courses already. But certainly, please read through these. You know, there might be a question about these on the exam. So just, you know, this, as I said, is, you know, what are the ethical responsibilities of system administrators, okay? And other people with privileged technical access, right? So definitely, please read through these. You know, it talks about some of the laws that, you know, like HIPAA or FERPA or Sarbanes-Oxley, et cetera. These are all kind of legislations that, you know, kind of put some, like, you know, teeth to this, right? So that you have to follow these kind of ideas. And so just follow along. There's the System Administrator's Code of Ethics, so professionalism, personal integrity, privacy. Privacy is big, right? So you have access to all the passwords, if you will, you know, the root password at least. Laws and policies, communications, system integrity, education, responsibility to computing community, social responsibility, and ethical responsibility. So, you know, as a sysadmin or a student is, you know, administrating a Linux system, etc., just make sure you read through these, okay? So the slides are very clear and concise. You don't have to memorize anything, just kind of try to understand this idea, okay? Right, and, law enforcement, that's why this, that forensic thing, that's why these two things are together, because the forensics also talks a little bit about law enforcement. So it talks about how to work with them, let's say that usually as a sysadmin, they would probably want to have access to a computer, right? That's ultimately what probably happened. And so this provides some information about, kind of the things that you'd have to do. If contacted by law enforcement, not about a crime that you're responsible for, but because you're a sysadmin, that will you'll be involved in the process. All right, and so it should be very interesting reading. And then just look at everything, just some suggestions about, what is expected, if you're a sysadmin, what is expected of you as far as notifying people or monitoring what's going on. The laws in the United States versus Europe, for instance, where privacy laws are actually drastically different. Being told to do something illegal or unethical, etc. Right? So make sure you read through these. Should be some interesting reading. Are there any questions, guys, about anything so far?
I don't have any.
No questions. All right. So again, we're talking about the files, file systems, and then a little bit of ethics, I guess. And now we're going to go back to file system and the file system analysis. Okay. So to do that, let me close these slides. So let me now go back to Brightspace. All right, so you should be seeing Brightspace. So we've looked at the slides, we've looked at the other slides, and this, as I said, this will be the home. This will be, let me actually do something. Let me take a look at this. Yeah, so I'm going to change these problems. So I'm just going to delete this file, actually. All right, so I think I deleted that. So hopefully you guys don't see that anymore. I'll just create a new one. All right, so let's go then. So we've kind of, let's go back to table of contents. All right, so we are here. And then I'll work on this. This is what this module will be for Wednesday. So now the last thing I want to do today as part of the lecture is think a little bit more in detail of if we have a file system, what would analysis of it entail, right? So I have this Word document here. You can see that. As I said, some semesters I do this as a lab, but I'm not going to make it a required lab this semester. Okay, so you don't have to do it. However, we can still talk about it and get a sense for it. So we already know what the file system is, right? So we already talked about it. We already talked about the different folders, and we already talked about adding things to this, organizing things. So file system analysis might be the scenario where imagine that, since we're in the idea of law enforcement, right, that we have a compromised system in your company where you work, you're the system administrator. So what they want to do is, let's say law enforcement comes in and they say, I want, or law enforcement wants, the sysadmin, and they might send their own people also to do this, so you probably wouldn't even have to do anything. But the process might be that they want to make a copy of that server. They want to create an image of that server, copy the entire thing, and then take that, and they're going to take it on their own to another computer. That's going to be like a type of forensic analysis computer. And that way they can take a look at the entire file system and try to find out, you know, different things about that file. Okay. All right. Okay, so let's see. So all Unix systems are organized within a single tree structure, right? Underneath one root directory. Leaves or nodes in the tree are separated by slashes, as we've said, so, you know, something like this, right? And there is no forest of directory trees beginning with host or network names. And there's also, let alone each disk having its own space, A, B, C. All right, instead, so even non-file devices such as terminals, printers, and disks themselves are abstracted and accessed via names in the file system, right? So this is kind of what we talked about in the lecture. So we just need to connect things to this tree, like we saw in the cartoon a second ago. So in order to make files or on a disk partition accessible, the disk partition has to be mounted. Okay, so it has to be mounted at some directory in the file system tree. So the df command, which you guys have already used this semester, right, allows you to see contents of a folder and the space available. Okay, this is really important because let's say that you're copying, let's say that you want to copy, you know, a file into your other computer. So you kind of want to make sure that, you know, that file system will in fact fit, right? And so taking a look at the size of the space available, et cetera, might be something useful to do. And so df can give you that information. So the file system provides little, if any, help when you want to know about the details of where and how it stores information. In fact, the entire purpose of the file system is to hide such detail, right? If a mounted file isn't currently being used, the umount command may be used to remove it from the directory tree. So it's a way of, you know, kind of like separating it out, okay? So you have the two commands, mount and unmount. So to better understand this case or this scenario, what we're gonna think about is that we have two computers. Let's call it computer A and computer B. And computer A is the, you know, forensic computer, forensic analysis computer. Computer B is the victim or compromised computer that you want to analyze. This, again, you know, this is just an example, right? So it's meant almost to illustrate how mount and unmount works, and don't really question the logic as to why you want to do it. All right, so there's also in Linux a fdisk command which displays any partitions on a given disk. All right, so you can Google this command there. Now, let's say that for this scenario we wanted to do the forensics, right? So one of the key things is we would have to send the disk image across the network. All right, that might be the more efficient way, right? So if you wanted to do something like that, you can create a tunnel between the two computer ends, right? So very much like SSH works, pretty much in fact. All right, so let's say that that's the scenario that we want to follow. We want to just make a copy of the entire file system of the compromised computer, send it through the tunnel across the internet, or not the internet, sorry. You wouldn't want to do that on the internet. You just do it within the local environment. You send it across the network, and then it arrives at the forensics computer. So basically, you know, if we have in the victim machine, we have the disk, right? All we have to do is we have to image. So we have to, the disk image procedure can be as simple as using Netcat. So Netcat is another tool in that you can use in Linux. It allows you to create basically tunnels. This is very much like redirection, right? So we talked about redirection, if you remember, in creating pipes where we could take some info and pipe it into the next step. That's sort of similar with Netcat. And so what you can do is basically from one computer, you start the Netcat and redirect information across the network to the other computer. So this is one way of imaging. So we can Netcat and copy the entire disk image and send it across the network to the drop-off machine. Now this, obviously, disk imaging over the network can take a lot of time because capacity of disk grows much faster when the bandwidth of local area than the bandwidth of local area networks. So, you know, for instance, let's say with VMs, you would want to make sure that you have enough space. So for instance, here's an example. We have a computer, 1204, which is 19 gigs of space. And it has 10 gigabytes available in space versus another computer, let's call it Seed B, which is of size 7. So in that case, this is something that you would want to check before you try to do something like this, so that to make sure that the 7 gig computer would fit in the 10 gigs available. Otherwise, you're going to you could brick, you know, B-R-I-C-K, brick the computer. And so, you know, you don't want to do that. So to do this process, then what you could do is first, you know, you could find out what partitions exist on the computer. So do df-h, right? And then once you've checked everything and you know that you have enough space available, you can go to the receiving machine. So this would be the forensic machine. And you would start a tunnel, right? So you would start a connection that basically says, on this computer, I'm going to start a Netcat on port 1234, right? So that means I'm going to listen on port 1234. Anything that comes through port 1234 of this computer will get redirected into victim.sda1. And that basically is the image of the computer that you want to send, okay? So that's all it is. Then once you've done that, the forensics computer is basically listening on port 1234. Anything it gets, it's going to redirect to victim SDA1. All right, simple enough. Then after that, you go to the compromised computer, and you're going to now run this command. And you can see this is going to be the image that you want to send, okay? So you go into the file system, you find where basically the entire file system is located, and you use what is called the dd command. The dd command, this just specifies the size of the packets that get sent. Notice that this is initiated, right, with the dd command. You copy the file system, and then you pipe it, right? And you pipe it, and where do you send it? You send it through Netcat, right? You're going to send it to what is called the receiving host. So what is the receiving host? It's the computer where you ran this one, right? That computer, remember, is listening on 1234. So here you would specify, you know, maybe the IP or whatever of that computer, port 1234, and that's it. That's how you redirect information. So you sent your information from the file system to that computer that is listening on 1234. The data that is received there will be sent to the file victim.sda1. So basically, that's how you can create the image, right, of an entire file system from one computer and send it to another computer. As you might imagine, once you have this one, what do you have to do? All you have to do is mount it into the file system of that computer. Now you can see down here, there's a little figure of how to do it. So here is, once again, you start this one, right? It's listening on port 1234. Then you start the dd command. It copies the disk, sends it through the Netcat, and then it comes out inside this machine and it creates the image file, which is called victim SDA1. Does this make sense, guys? Are there any questions about this idea?
I think it makes sense.
Yeah, and so it's just, you know, it's just an example of how to deal with the file system and create images. Now, you might argue that you should be sending the data encrypted and all of that. So the procedure is really pretty much the same, except that there's going to be an additional step of, you can read through it. I mean, it's pretty clear, I think, but there's going to be an additional step of just creating a tunnel between the two computers, an encrypted tunnel between ports. And then that way you're just going to redirect things. So for instance, here, notice it's the same graph, the exact same procedure, but now between Netcat and client and server, you create an SSH connection, an SSH tunnel that ends in port 2345 here and ends in port 1234 here, right? So that's really how it is. And then that way now, whenever you send the information from the disk partition, you actually want to go into that 2345, which immediately goes through the encrypted tunnel and ends up in 1234. That's really all it is. But it's pretty much, if you understand this idea, then this one just creates that SSH tunnel in between. All right. And then once you do that, that may take a while depending on the size of your file. So you can always check the size. And then finally, hopefully, if you're successful, you have now received a file called victim.sda1. Right? Once you have victim.sda1, that's your image. You just image a file system from one computer and moved it to another computer. All right? Now that you have this, this idea of having the whole image of the disk of computer compromised in the computer for forensic analysis, now the key question is, well, I just want that to be accessible in my file system. So that's where the command called mount comes in. So you can see here, it's highlighted. You can do mounting of disk images on an analysis machine. And the process for this is also pretty straightforward. You can, you CD into some folder, maybe root in this case. You can create the directory, so call it victim, for instance, right? Something like that. And then you just have the mounting command. So there it is, mount, and then it's got some parameters, okay? If you wanted to unmount, then you would go into the folder where you mounted the file, and you would just run unmount victim. And that's it, right? So that's, so sometimes, assuming it's a compromised machine, the perpetrator or whatever, whoever did this might be very clever, right? And they might put, like a computer virus or something in the file system so that when you load that, it actually attacks your machine. So some care is needed when mounting a disk image from an untrusted machine. And there are some parameters that can be used, for instance, non-execute mount option to disallow execution of untrusted programs on that disk image. This can help to prevent contamination of the analysis machine by unintended execution of malicious software. So basically what this is saying is very much so like access control in files, right? You can also set an access control that basically makes something, non-executable, read-only, that kind of thing. And so that mount has those properties. All right. All right. So you can create the victim. Now, keep in mind, as I said before, if there's a file in that folder, say foo.txt, and after you mount the image, you will not be able to read that file anymore, okay? you will only be able to access what was in the file system of victim SDA1. Okay, so here is the command now, mount that file into the victim folder, and then some parameters so it's non-executable and so on. This will mount the file into victim, and now the contents of whatever you had in that image become available in your file system. So it's abstracted for you. So that's, that's the whole point of this case, just to kind of illustrate this process. All right, a few other things. Let's say once you have the file and you can navigate through it and you can see it, then there, you might install some programs like the Sleuth Kit or Autopsy or anything else. These are mostly forensic tools that you can then, kind of unleash on this victim folder, right? And so it'll give you statistics about, maybe there was some deleted files, but as it turns out, those deleted files are still there in the file system, right? So it can recover them, or it can give you data. And so that's beyond the scope of this class. Of course, this is not a forensics class, but I just wanted to point out from the point of view of the file system and mount and unmount how all of this can be done, okay? And that's it. So we've talked about a lot of concepts. I think this is a nice way, I think, of kind of discussing these topics, because we have a nice little problem that we can take a look at. Now, remember, again, this lab I'm not going to require this semester, okay? So just read through it, certainly. Now, there could be questions about this on the exam, okay? So that certainly can happen, but there won't be a link or anything. You don't have to submit this assignment. All right, are there any questions about any of these ideas of, let's call it file system analysis? Anything you guys didn't understand? No questions? All right. All right, so if there are no questions, then as you can see, that kind of was the main lecture for today. I just have a few lectures left at this point. So file system is certainly one that I wanted to cover, as that is central to Unix. So we've gone over the handwritten slides, the digital slides, type slides. Remember, read up on ethics of a system administrator. And we went over, mount and unmount, creating images, and just file system issues in general. All right. So that concludes the topic of file system. This week, so now we can move on to kind of the lab part, the lab portion for this week. All right, so here I'm going to have some scripts, as you know, several miscellaneous scripts that we're going to do related to sysadmin. Some of them will relate to file system, but not all of them. So there will just be a good mix of different things. So let's take a look at this file first. So you can see these are some of the problems that we will do. I'll change this, of course, but some of the things that we're going to explore are basically related to services. Okay, so HTTP, SSH, FTP, tar, PDF. So I'll talk, there's a lot of topics here, and it's just better to kind of talk about them on a script. I will also add a few here related to the file system. You saw them in the previous document that I deleted. So I'll just update this file. Now, this case Aurora, let's take a look at case Aurora for a sec. And you can see here, this is an interesting case. There's also a summary of some of the problems that we will do, right? So that I'll start doing between today and Wednesday. But case Aurora, this is, you know, yet another one, right? So this is a case, a situation that happened, and then you have a system administrator. So Operation Aurora, let's just read through it. Operation Aurora and how the obvious was missed. So the idea with these, again, is that since we're going to be doing scripting, you know, we might want to think in terms of a system administrator, what they face, and how could they have attacked that problem, right? So how can they deal with it? So let's take a look at this one. Operation Aurora and how the obvious was missed. On January 14, 2010, the United States learned of a coordinated, sophisticated, and prolonged computer attack that targeted Google, Adobe, and over 30 Fortune 100 companies. Okay? Dubbed Operation Aurora after a folder found in an infected machine, the attack used a novel exploit unseen before in the wild. Although Microsoft knew of the vulnerability exploited in the attack, they falsely assumed that nobody else knew of the vulnerability, and therefore no mechanisms existed to detect such an attack. To exploit their victims, the attackers initiated the attack by sending the victims an email with a link to a German website with malicious JavaScript. When the user clicked on the link, you all hear of this, right? This is called phishing. So when the user clicked on the link, they would download a piece of malware that connected back to a command and control server located in Germany. Okay. From there, the attackers used their newly gained access to hunt for proprietary information stored on the exploited victim's system. As obvious as this attack appears, it went undetected for several months and succeeded in penetrating the source code repositories of several Fortune 100 companies. All right. So, sorry. So as I said, we're going to take a look at some scripts, and the idea here is that maybe this problem could also be solved, you know, with some tool or writing a script or something. So you guys heard me talk about it, right? You heard me read it, basically. Now, how would you're a system administrator. You work in one of these companies. What do you do? What do you propose? Keep in mind, this was 10 years ago, so who knows the complexity of new things, right? New things will be even more complex, but how would you begin to tackle this? What do you think?
Would you be able to run an Nmap?
Say that again?
Would you be able to run an Nmap on it?
What?
Over the actual mapping of the system of where the computers are being run to?
What do you mean by that? Elaborate.
So, like, you said that they get run out of the actual company itself, so be able to map out where the computer's data is being routed to by using Nmap.
Oh, okay. So how would you use Nmap exactly? What would you need to know? Because your computers, you can Nmap your computers, correct?
Yeah.
And then get like open ports of your computers in your network. How does that give you, because remember, you don't know what's going on. You're just a system administrator. You've sort of heard about this. You don't really know what the exploit is, but you know this information, what's said here in the document. How would you use Nmap, or how do you tackle this? What do you think? You're onto something. I believe you actually have the idea. You just haven't.
Yeah, I'm trying to figure out how you would actually be able to, if you just know the very basics, how do you get the specifics?
Mm-hmm. So what is your goal here, right? So when you said Nmap, forget about Nmap or the tool.
Mm-hmm.
It's, write your code in Python, right? So forget about some tool. What is the goal that you want? I think you were right. You were onto something there. What is the what is the goal? What is the, how do you know something is happening?
Sorry, my cat's kind of.
Yeah, I can see you. I could hear your cat.
If I could jump into
Yeah.
attempt to answer.
Yeah.
So you would want to know where exactly it's coming from, and then with Nmap you could figure out what ports this is coming through.
Okay, so and yeah, Nmap would give you open ports, but how would you know? Okay, I'm mapping the ports. Let's say it's going to multiple ports, because remember it's coming through an email, right? And then it's launching this malware. It's you're saying basically the malware is probably opening a port on that computer, correct?
Or using one that's like open by default or something.
Yeah, what if there, exactly? What if there's one that's open by default and it's using that, and it's actually you have it open intentionally for something good? So that
This is a closed network, correct?
Say that again, sorry.
This is a closed network since we're.
You're in your company, so it's the internal network. Remember, you opened an email, you clicked on the link, it downloaded a program, you didn't even see it, and now that program, according to this, is running. And what is it doing? It's it says it's a piece of malware that connected back to a command and control server located in Germany. And from there,
So would you be able to see any sort of foreign data being moved back and forth since you're in an enclosed network?
Mm-hmm.
So with that information, you're able to see an anomaly.
Oh, so you're.
But I'm sorry.
So what is one of the tools, not Nmap, but another tool that we've used to look at network traffic this semester? Wireshark, right? So we remember Wireshark?
Oh, that makes sense.
Yeah. So it's actually it's a network traffic scanner, if you will, right? And as it turns out, some IP addresses in packets can be geolocated. You know what I mean?
I do.
Yeah, and so that's actually, think about it. It seems like such a complex problem if you first think about it. It seems like, oh, it's impossible to solve this. And then if you think about it, well, actually, the packets are going to some country that you usually do not do business with, right? Let's say very local. So you don't really do business with this country. So then it's in your best interest maybe to monitor your network for geolocation. And so by not necessarily with Wireshark, but just any network traffic scanner, right? You could, for instance, scan the packets and look at where the packets are going. And usually what you can create, which is actually what we're going to talk about next week, is monitoring networks, right? And so usually that's usually referred to as a network operations center. And one of the things that you could have on your big screen is a map of the world, right? A map of the world. And then by doing geolocation of the traffic as it's coming and going, you could actually see sometimes, maybe you would see some red coming up in Germany of your packets. And then you're like, okay, what's going on? Why am I sending traffic to Germany when I don't, you know what I mean, guys?
You're able to just kind of track your packet and see of where they're going, where they're being sent to.
That's right. That's right. And that's it. That's the solution. I mean, that's a solution to this, is that, because here it's saying the attack went undetected for several months, right? And they caused damage. And if you think about it, they were probably sending tons of network traffic, right? If they're stealing like source code repositories, copyrighted information. So it probably means that, you know, I don't know, 3 a.m., you're seeing all these packets going to Germany, according to this. And so if you just had scanned the packets, you know, like Python script that runs through a cron job, I mean, you don't need any fancy product, right? You just write a script, run it through cron jobs, scan the packets every now and then geolocate them. There are some libraries for geolocation. And then based on that, basically flag countries, you know, that are not your normal business partners, maybe view it in a nice way. The map is just, you know, for be nice. You can always just print a report, but then you look at that, and then you actually try to figure out what are these packets, right? And then you might identify, okay, I got all this traffic going to these addresses, and then of course from there on, then this just detects. But if you want to take a preventive action, then you go to the firewall and you know drop those packets, right? So you put in an access control list rule to stop that. We will see. That's kind of one of the last topics, firewalls in Linux. We'll cover that in a few weeks from today. But anyway, that's kind of the scenario. Does that make sense, guys?
It does.
All right, so you know I like to do this case. It's kind of fun, I think. All these scripts, by the way, that we're gonna start using this week, I already posted online. So I just want to point you to. So you should be seeing. Let me share. All right, so this is so we are here, today is this. And then as you can see we've done already the case Aurora, right? So I went over that. There's a lot of little scripting things that we're gonna do between today and Wednesday. And then I'll create just one document, a list of problems of what I want you to do. But just before we begin this process, as usual, I wanna point out that I've already posted the code, and it's on the GitHub. So if you click on the GitHub here, you can see all the files are here, right? So tar file, SSH, simple HTTP, PDF, geolocate, right? That's the one I just talked about. FTP interaction. Now this geolocate, by the way, sometimes in the past, in other semesters, students have asked me that they want to implement this as a project, as that project B. You can do that if you'd like, right? So that's usually why I don't assign it as a lab. We just kind of discuss the case Aurora. You can take a look at this code and then implement that as your project B. Remember, project A is getting Hadoop working. FTP interactions, you can see we'll play with a few services and commands in Linux. And then obviously all the other things, file system, right? What we talked about today. Some of it is here. Map redos, if you remember, we're also going to cover a little bit of this, some of these scripts. So all of them are there, is my point, right? But we're going to start working through these, and some of these will be homework. All right, so I just wanted to point that out, all right, given that we do have a few scripts this week. All right, so the first problem that we're going to, so we've done case Aurora. Now, there's no better way to call this than just like miscellaneous scripts. So the next one that we're going to look at is this idea of that ties back to the Hadoop lab, right? Which is how to do something in parallel. How do you do parallel scripting? Okay, so let's take a look at that. So I'm going to switch to the whiteboard, right? And you can see here, so if you remember, you know, when we were talking about, before spring break, if you still remember, we were talking about map redos. We were talking about map redos, right? And we were talking about how this is done for parallel computing. So the idea here is that you build a cluster of computers, remember, with the Hadoop framework. They're all connected, right? And basically then you're gonna do a problem like count words in a set of documents. In a set of documents. Okay, so you're going to count the number of words. But what you can do is you can, let's say these are the documents. You can send a part of them here, part of them there, another part here, and so on, right? And we talked about that already. And then Hadoop itself would do this in parallel. So this is your project A, of course. Okay. Now in the scripts, however, this week, I'm going to do a simplified version of this. So I'm still going to use basically the same scripts that I would use in Hadoop, right? I'm going to use, but without the Hadoop program. Okay. So what I'm going to do is I'm going to have the same problem. Okay. I want to have the same problem. I want to count. I'm going to think of it this way. You know, I have a couple of computers, and each one gets a set of documents, and then I'm going to run a couple of scripts called mapper and reducer. Mapper and reducer, right? And these two scripts will allow me, given these, I'm going to count them, and then I'm going to basically summarize them, you know, get some statistics. And then this one would do the same with the same script, mapper and reducer, and then this one, so this is computer 1, computer 2, computer 3, same thing, mapper and reducer with its own corresponding set. At the end, you end up with results on 3 different computers, and then somehow they could be merged together. Okay, they could be merged together so that you end up with one final result. So let's just say final. Okay, so it's going to be similar logic to how you would do it, you know, but without Hadoop. Okay, and then hopefully this will help you by doing this problem. It'll help you to better understand how this would work in the Hadoop environment. Okay, and here we're just gonna, this is a problem where we end up using a lot of the things that we've used before. Okay, so we're gonna use a lot of things that we've used before to do our counting. So now let's think about it. So obviously I did this example with 3 computers. You don't have to do it, just follow along with me. But basically we're just gonna do it for 1 computer. Okay, 1 computer. So now let's go over here and let's think about it, right? So I'm on my Linux computer now, 1 computer. What do I need? I need some files. So let's say I do ls. I'm going to go to the project Gutenberg, right? Gutenberg.org. It's a place where you can get open source books of all kinds. So maybe we're going to get some books from the Brothers Grimm, Beatrix Potter, you know, that kind of thing. So let's say I get a file, potter.txt. These are, we can download the ASCII files. Okay, so I'm going to download Potter, you know, Grimm. I don't remember the names, but, you know, they have, these are authors that have or anything that you want, really. You don't have to, you know. So basically then what you would do is on that computer is, let's say that, you know, if you were doing this in parallel, you have other books will go in other computers. But here we just have these two. So the first thing we would do is basically we just grab the files and do something like cat potter.txt grim.txt. We'll do this on the computer on Wednesday. Today I just want to go over the idea. And then what do? You take these two files and you pipe them. It is literally that simple. That's, you know, you don't have to write a shell script. You don't have to write a Python script. You just literally cat them in and pipe them. And now the contents of those files has been sent to the next step. So what's the next step now? The next step is maybe, possibly here, running the Python script. And so we're going to call it a mapper.py. Now, mapper has to somehow read the words, right? So it has to read just the words that it has been given in some way, right? Remember it in a parallel way. So the map, so that's what we're gonna take a look at on Wednesday, is how would we write that code? And you'll see that it's actually pretty straightforward. But because it has to be in parallel, it's a different kind of approach. Once I have the values here, maybe I want to do something to the output of Python, right? So Python, we will use like standard in and standard out libraries to pipe to the next step. And in the next step, remember, you can do lots of things, right? So, you know, what are some of the tools that we have? We have grep and awk. We have grep and awk. Okay, then we also have, what else do we have? We have actually other things. We can do a sort. We might want to sort the words in such a way that, you know, that makes counting efficient. So we can do that. And, you know, all kinds of things, right? All kinds of things that you, but notice that here we're mixing scripts with built-in commands, etc., and just piping. And then after that, after our process data is correct, we might want to use the reducer. So Python reducer .py, right? You can see that there. And then Python reducer gives you other data. And then guess what? What we just learned in the file system analysis, right? File system analysis lab previously, we could use Netcat and see, right? And what do we do here? We say that, you know, we want to, via SSH, right? Let's say, I'm not writing the actual syntax, but kind of like what we did in the previous example with file system, we netcat to an IP and a port. And then what does that accomplish? It accomplishes that we can do the processing in one computer and then send the results of that via Netcat to another computer in the network. So ultimately now we have a mechanism where we have a central computer, right, that receives the results from 3 computers. So basically what we're doing is we're creating our own little Hadoop, right? Our own little Hadoop. We have computer 1, computer 2, computer 3. Each of these is running their stories with the same scripts, mapper and reducer, some processing here, and finally a redirection. And there are various ways of doing these redirections, but you send the results of all computers to one centralized computer, which then, of course, this one has to be listening. So this one is listening on some port. And then it receives the output and then processes it to arrive at a final result. So this is a poor man's Hadoop, if you will. Poor man's Hadoop. Now, is it parallel? Well, I would say so, because you have this computer, that computer. They're part of the processing of the data, right? And then you can just redirect the data to the final computer that, and very much like we did in the file system analysis example we just looked at a second ago, where we were creating tunnels, and actually you saw in the Hadoop description before spring break that Hadoop actually uses SSH to communicate with the machines, right? So technically we could build something. It probably won't be as efficient as Hadoop, but as I said, that's why, you know, you can call it a poor man's Hadoop. Now, we're not gonna build all of this, although again, this could be a term project. If you guys, for project B, if somebody wants to build this and kind of, you know, measure it, that would be one key thing. You know, if you have to count all these books in just one computer versus running it in several, you know, is that faster? So that'd be an interesting thing to look at, given that, remember, this is being sent in the network. So it falls into that bottleneck, as we discussed. But anyway, it's a good project. As far as what we're going to do on Wednesday, we're only going to take one piece of this. So we're just going to take like one and do the processing there. But I think the rest you can figure out on your own. Does this make sense, guys? This is just a big picture so far.
Yeah, it makes
Any
sense.
question? No questions? All right. So we'll stop here for today. So this is where I'm going to pick up on Wednesday. Just start with this, doing this scripting, and then, as I said, finish up some of the miscellaneous topics. Next week, we will start Snmp. All right. So I'll stay for a couple of minutes if you guys have any questions. Otherwise, I'll see you guys Wednesday.